Hello students, in this class let us see what are quantum numbers. So what is the importance of each and every quantum number also. So first, what is the need of quantum numbers here? To identify the position of an electron, or simply to describe an electron in an atom, we need the assistance of four quantum numbers. Let us see what are the four quantum numbers here. So the first one is principal quantum number. So let us see what are the important things present in principal quantum number. So in that, first one, actually it was proposed by which one? Niels Bohr, and it is indicated with small n, and n can take values from 1 to 3 up to infinity. And here, what is the importance of this principal quantum number? So principal quantum number describes the energy of an electron. Describes which one? Energy of an electron. And some other important facts regarding this principal quantum number. By using principal quantum number, one can determine what we can determine: number of subshells, number of orbitals, and also number of electrons. So now here, number of subshells equals to formula n, and then number of orbitals equals to n square, and then maximum number of electrons formula is 2n square. And also one can determine radius of the orbit, Rn equals to 0.529 into n square. So these are which one? Angstroms. Okay, then one can determine the energy of electron also, minus 13.6 by n square electron volt per atom. And similarly, so we can determine which one here, that energy of electron and also radius of the orbit and also angular momentum of electron. So what is the formula to determine angular momentum of electron? Nh by 2 pi. So these are the important things we have to remember regarding which one? Principal quantum number. And what is its importance means, principal quantum number determines the size of the orbit, and also that means here energy of an electron present in that particular orbit. So this is regarding which one? Principal quantum number. And next, let us see another one here, azimuthal quantum number. So what is azimuthal quantum number? Let us see. And what are the important points we have to remember. Okay, the second one is here, azimuthal quantum number. Azimuthal quantum number. So listen here, what is azimuthal quantum number? So now it was proposed by which one? Means Sommerfeld. It was proposed by Sommerfeld, and here it is indicated with which one? Small l. And here L can take values from, what are L values? From 0 to n minus 1. L can take values from 0 to n minus 1. And here, now if you consider n equals to 1, what should be the L values? Or L value means 0 to n minus 1. Means 0 to n value 1. So 1 minus 1, that is nothing but L value 0. If L value 0, that indicates S subshell. That means first orbit contain only one subshell, that is S subshell. Now come to the second orbit. L values are from 0 to n minus 1. That means 0 to 2 minus 1. That means 0 and 2 minus 1 means 1. So now what are the L values in second orbit means 0 comma 1. These indicates presence of S and P subshells in which one second orbit. Now if you come to the third orbit, L values are from 0 to 3 minus 1. 0 to 3 minus 1 means 0 to 2. That indicates 0 comma 1 comma 2. These represent SPD subshells present in which one, that third orbit. And if you consider n equal to 4, L values are 0, 1, 2, 3. These are indicating S, P and D, F subshells. So like that, fourth orbit can accommodate for four subshells S, P, D, F. So this is another importance of that azimuthal quantum number. Okay, then using azimuthal quantum number, one can determine which one number of orbitals present in that subshell. So now that formula for number of orbitals is equals to 2L plus 1 and number of electrons equals to number of electrons formula 2 into 2L plus 1, because each and every orbital can accommodate for 2 electrons. So we have to multiply with number of electrons with which one, 2. So therefore 2 into 2L plus 1. This is regarding which one, number of electrons. And orbital angular momentum. What is the formula for orbital angular momentum? Let us see that formula here. Under root L into L plus 1 H by 2 pi. So this is importance of which one, that azimuthal quantum number. Okay, then another one here, magnetic quantum number. And before going to magnetic quantum number, what is the importance of azimuthal quantum number? So azimuthal quantum number indicates the shape of the subshell. That means S subshell is having which one, spherical shape. P subshell is having dumbbell shape, and D subshell is having double dumbbell shape. F subshell is having, that means that not determined exactly, somewhat difficult. That means it is a four-fold dumbbell but complex structure. So like that, azimuthal quantum number indicate that describes about which one, shape of the subshell. Okay, now let us see which one here. Third one is magnetic quantum number. Let us see what is magnetic quantum number. So magnetic quantum number proposed by Lande. Lande proposed which one here? Magnetic quantum number. So what is the need to propose magnetic quantum number here? So very simple, that to explain the Zeeman effect and Stark effect, now we need to use which one here, means magnetic quantum number. Okay, now let us see here what is the description of magnetic quantum number. It is indicated with M, and total M values are how many, means here 2L plus 1. Total M values are how many? 2L plus 1. Those values are from minus L to plus L. Those values are from minus L to plus L. So one example here, for S subshell, now let us see L value 0. Therefore M values are 2 into 0 plus 1 means only 1. That means S subshell is having only one orbital, And what is that magnetic quantum number value means? Minus L2 plus L means minus 0 to plus 0. That is nothing but which one? 0. Okay, now let us go for P subshell. What are the M values for P subshell? Let us see here. So we know that P subshell is having L value is 1. Therefore, total M values formula 2 into 1 plus 1 means total M values are how many? Means 3. And those M values are from minus 1 to plus 1. That means minus 1, 0, plus 1. That means P subshell is again subdivided into three orbitals. Those are px, py, and pz. These magnetic quantum number values minus 1, plus 1, and 0. So this is regarding which one here? P subshell. Now let us see that D subshell. So now D subshell is having L value is how much? 2. So D subshell L value is 2. So therefore total M values are 2 into 2 plus 1 means total 5 M values are there. What are the M values here? Minus 2 2 plus 2. That means minus 2 minus 1 0 plus 1 plus 2. So these are the magnetic quantum number values for which one? 5d orbitals. And similarly for F subshell, L value is 3. Total M values are 2 into 3 plus 1 means 7. Those are from minus 3 to plus 3. Means minus 3, minus 2, minus 1, 0, plus 1, plus 2, and plus 3. So these are the 7 magnetic quantum number values for which one? F subshell. So this is regarding which one here? That magnetic quantum number. And what is the importance of magnetic quantum number? This will describes the orientation of orbital in the space. So that is the importance of which one? Magnetic quantum number. And next another one is there, that is spin quantum number. So this was proposed by Woolenbeck and Goudsmith, indicated with S or MS. And here this describes about the spin of the electron. If electron spins in clockwise direction, now let us consider spin is plus 1 by 2. If electron spin in anti-clockwise direction, what is the spin? Means minus 1 by 2. Now, after writing all these individual descriptions, let us write all of them put together in which one? In a box. Okay, now let us see what we have to write here. First, let us see here principal quantum number, and then here we have to write azimuthal quantum number. Then we have to write here magnetic quantum number, and then we have to write spin quantum number. Like that we have to divide that sheet into which one here? 4 columns. Now here let us write first one principal quantum number. If principal quantum number value is 1, azimuthal quantum number value is 0. At that time magnetic quantum number also 0. Spin is either plus of or minus of. And if principal quantum number is 2, that azimuthal quantum number values are. So here what are that values? 0, comma 1. And here magnetic quantum number for 0, 0 only. If azimuthal quantum number is 1, magnetic quantum number values minus 1, 0, plus 1. And here the same, that is plus of or minus of spin quantum number. And if n value is 3, L values are 0, 1, 2. If L value 0, M value also 0. If L value 1, here minus 1, 0, plus 1. If L value 2, M values are minus 2, minus 1, 0, plus 1, plus 2. For all these, spin quantum number is as it is same. That is how much means plus of or minus of. So this is regarding which one here, quantum numbers. So this is one of the important questions for intermediate public exams. Okay.